Good day, guys. I hope you're all doing so well. So today I'm going to deal with or I'm going to teach you on how to prove theorems, and this is theorem number 1 of circular geometry, grade 11. And guys, can you just please memorize or understand this theorem, because it is examinable at some point, so you need to understand it or know it before you can go or write your trial examination or even your final examination of mathematics paper 1. So I hope you can enjoy the class. Let's just start. So we are given a circle with center O, and we have a chord and an angle C that is perpendicular. We have a line perpendicular to AB. So at point C we have 90-degree angle here. So the theorem, it says that if we have a line, from center of a circle, guys, you need to remember you guys captured the concept of circle in grade 8 and or grade 9. We have a second, we have a radius, we have a diameter. So we go and learn those things so that you cannot be confused when we talk about perpendicular lines, we talk about chords, second, center, diameter, radius in this concept. So we're going to deal with a lot with those definitions, so you need to be familiar with them so that you can understand what I'm talking about going forward. So but I will just try to explain other definitions as you go, just like diameter, radius, chord. I've got you guys, relax. A line drawn from center of a circle. Center, we have center O, perpendicular, which means we have a line OC. This line is drawn from the center, which is O to point C, and this line, it is perpendicular to a chord. Which one between line OC and line AB is a chord, guys? You need to know if we have a line that touches one side of the circle, or one side of the circle and the other side of the circle, or if you have a line that touches at one point of a circle and the other point of the circle, or the circumference of a circle, that line, it is called a chord because it touches this side of the circle and this side of the circle. This line AB is called our chord. So a line drawn from center of a circle perpendicular to a chord, meaning this line is drawn and it is perpendicular to this chord AB, meaning at point C we have a 90-degree angle there, meaning C2 and C1 equals to 90 degrees, each equal to 90 degrees angle. So they say that this chord bisects, meaning when you have a line perpendicular to a chord, it bisects that chord, meaning that perpendicular concept of saying angle C is perpendicular means it bisects the chord. When you talk about bisection, it means the lines or the sides that form the part of the chord, they bisect one another, meaning AC is equals to CB. They bisect one another. So that is the concept of when you talk about lines that bisect one another. So yeah, now guys, I hope you understand this theorem number 1. So we are given that center O. We are given center O. Before anything, in circular geometry, when proving, we have 4 heads. We must label the given, the one that you are required to prove, you must construct, and now you can prove now. So we have 4 heads in theorem, in proving theorems. So don't be confused when I talk about given, required to prove, construction, and proving. So I'll just explain as we proceed. So we have center O, and we are given that OC is perpendicular to AB. Done, guys. Then we are required to prove that that line bisects the chord. I mean, this line, when we have line OC that is perpendicular to line AB, meaning when this line is perpendicular, meaning OC is perpendicular to AB, or when OC is perpendicular to AB, it means AB is bisected, meaning it is cut into 2 pieces. And we need to prove ukuthi indeed it bisects. Basically we're saying ukuthi AC is equals to CB. We are going to prove that AC is equals to CB, guys. I hope you understand. Then construction, you need to construct all the time. By all means, you need to construct. When you prove theorems, at most times you are required to construct in the examination. So you need to know in theorem number 1, you construct radii. I'll just show you right now what is a radii and how do you spot it on a question. Radii, guys, do you remember we have, let me just teach you something. We have a radius and we have a radii. Remember, guys, a radius is the half of diameter, meaning radius, it is a line from center. It is a line from center to a circumference. That is our radius. It is our singular. It is one line. Then we talk about radii, we have plural. We talk about plural. Basically, we have 2 lines from center to circumference. It can be line from here to the circumference, or line from here to circumference, line from here to circumference, and whatsoever, guys. But in this case, this line, it starts from the center, meaning you need to form 2 triangles. Basically, you are forming 2 triangles here. So this line, it starts from O to A and O to B, guys. Those 2 lines are called our radii. Radii does not matter as long as those lines are more than 1. You can have line from center to the circumference here, at this point, whatever. As long as those lines or those sides touch the circle at the center to the circumference, those are called radii, and their lengths are equal. Basically, AO is equals to OB. You must memorize this, guys. You must memorize this. Even in other theorem that you're gonna deal going forward, you're still gonna meet radius. So you need to memorize ukuthi radii are equal. OA is equals to OB. Then you are done, guys. Yes. Now we have triangles now. So construction, we have constructed OA and we have constructed OB. Yes, that's construction. So let's prove. So what do we prove? We prove that indeed triangle OCA, it is congruent to triangle OCB. Congruency. Why do we involve congruency? Because we have congruency is all about triangles. Proving triangles, sides and angles of triangles that are equal. That's congruence. The hence would include or involve congruence. So we have triangle OCA that is congruent to triangle, meaning to prove that the OCA is congruent to triangle OCB, guys. I hope, guys, you understand what I'm talking about here. So I hope you have an idea of how you're gonna roll out going. So you can pause the video and prove congruence. So for you guys to successfully prove congruence, or for you guys to know that in which circumstances or in which parts or in which situation do we prove, or are we required to prove congruence, or in which situations or given situations in triangles are we required, or are we forced, or are we able to prove congruency? So when we have 3 sides, when you have let me just the heads of congruence. So when you have side, angle, side from both triangles, when you have a angle, yes, and side. When you have right angled, right R for right angled, hypotenuse side and side. I hope you understand, guys. So right angled hypotenuse side, right angled hypotenuse side, and the other one, it is I hope, guys, you still remember. Yes, that one is side, and yes, and side. Yes, guys, and side angle. Yes, side angle. I hope, guys, you understand. Let's just prove this. So statement and reason, guys. Statement and reason, it is my clear to all of you. Let's use statement and reason structure to put our proofs accordingly. So accordingly, yes. So guys, you must just construct a table of two sides, segment and reason. So a good table. So don't just follow what I'm drawing here, but you're not draw it in a proper way. So yeah, statement and reason. So we are given number one. What do we need to prove here? We know that let's start with the given. Which side or which two angles that we're given that are equal on the diagram? We're given that C1 is equal to C2. Simple, C1 equal to C2, each equal to 90 degrees. Angle C1 is equals to C2. Remember, we check from these two triangles OCA. Angle C1 of OCA is equals to angle C2 of OCB. I mean triangle C2 of OCB. Yeah, angle C2 of OCB. Sorry guys. Then each equal to 90 degrees. Why? Given. So when you talk about given here on the reasoning, it is because of this 90-degree angle. It is visible on the diagram. Hence we talk about, or hence involve a given here. Then number two, second proving is that let's check when you check a triangle OCA, which angle or which two angles between this triangle and this triangle are equal, or which two sides on both of the two triangles are equal. Guys, so let us remember that OC or side OC is available on triangle OCA, and OC again it is available on triangle OCB. That means OC is common on both two triangles. So when I say OC common, you can just say OC common, or OC is equals to OC reason common. Then number three, guys, the last one by the way, which two angles from both of the two triangles are equal, or which two sides from both of the two triangles are equal? We talked about radii, remember? Radii, OA and OB are equal. Those are radii. So yes, OA equals to OB. Reason radii. Therefore, you conclude, guys. Therefore, triangle OAC, it is congruent to triangle OBC. Reason, right angle, hypotenuse, side. I will explain this right now. So guys, remember, in your conclusion, meaning your triangles or the triangles that you have after you have proven the sides are equal or the angles are equal, need to make sure that this type of concept is in order. Basically, when I check here and this, what you have written here needs to correlate with what you have proven here. In which way? You can see that meaning it must be in order. You can see that OA, it is here, OA from this triangle is equal to OB from this triangle. Or when it's in order, then OC, meaning it's their placement when you conclude needs to be in order. OA, OB, OC, OC, I mean OC, or OC, OC. Their placement is in order. OC, OC, OA, OA, then C1, C2, C1, C2. One is in order, guys. Then just come back here. Right hypotenuse side. Simple, Remember, angle C1 and C2 equals to 90 degrees. Right angle. R for right angle. Then you have hypotenuse. Remember, radii, OA and OB. OA and OB our hypotenuse side. H for hypotenuse. Then we have S. S for, remember, OC equals to OC. Common. This is our side. This is the last side. This is the remaining side. I hope guys understand what I'm talking about here. Let me just make an example from a previous paper with regards to this concept. But guys, remember, there's a reason you use when proving congruence. So a reason, if you have a situation like this, in the next few examples, I'm going to show you ukuthi we have proven that therefore we have proven ukuthi AC is equals to CB, where from congruency, from congruency, this is the congruency. So in the future, or in the near future, maybe in the examination term 3 or even in term 4, when you just prove, or when you are given a triangle, maybe in an example, and they just show you kuti, or they just draw a triangle without showing you kuti AC equals to CB. But if they draw kuti angle C equals to 90 degrees, you should already know kuti, and we have a center and a radius and 2 radii. You should already conclude kuti, okay, if you have a right angle here and a center and you have radii, therefore AC equals to CB. Why? The reason why do I be saying with AC equals to CB? The reason you're gonna use going forward is that perpendicular line from center to chord is the reason you're gonna use if AC equals to CB. When it is not given on the diagram that indeed AC is equal to CB, or when you're not given that they bisect each other, if and only if you have angle C that is equal to 90 degrees and a center that is radii, or even if they are no radii, but you can just, in terms of construction, you can just construct those radii or radii. But if ever you have a center, a line from center to chord that bisect the chord, or that is perpendicular to the chord, which is angle C equal to 90 degrees, even given that AC equals to CB, so you must just conclude, okay, if you have a right angle here, that means AC equals to CB. Why? Perpendicular line from center to chord. Guys, let us make an example, or let me just help you guys to solve an example in the next few seconds. Hey guys, this is an example, simple one. This is so simple, guys. It's so simple. O is the center of the circle. O is the center of the circle. SP is equal to 100 millimeter. From here to here equals to 100 millimeter, guys. Simple, ne? Then OT is perpendicular to QP. OT, QP perpendicular. Remember, guys, remember. And OT, where is OT? Here. OT is equals to 40 millimeter. Ne? Calculate the length of QP. Yeah, we want the length of QP. This is the length. We want the length of QP. Simple, ne? Just construct the statement and reason table for you to know what you are doing when you are busy solving or when you are busy finding values or answers. Statement and reason table, ne? Yes. So you must just use a ruler to construct, ne? Yes, guys. Number one, guys, let's just prove. Okay, so guys, we need to know the value, or find the value of QP, I mean. So I can just use Pythagoras, ne? Because I've got 90 degree angle here. I can just look at it and use Pythagoras in here without going extra mile. But for you guys, for the sake of some of you don't understand how will we use Pythagoras when we have only one full side that we know. Hence, because you cannot use Pythagoras if we have a SP only, because I don't have OP. According to some of you, you may think we don't have OP, we don't have QT, so why do you use Pythagoras? I'm gonna show you how you're gonna find the value of OP and TP. Yeah. But let me just explain theorem number one. Let me just go back to what I've just told you guys. Yeah. So let's just check here. We talked about radii. Yeah. I'm sure you guys have talked about radii. We said radii is a line from center to circumference. Yeah. a line that touches center, or length from center that touches the circumference. This is the line, first line. Then the second one is another OS, and the second one is OP, line from O to P. It touches the circumference also. It means those lines are equal because they are called radii. So OS is equals to OP is equals to, remember guys, SP is equals to 100. That means if they're equal in length, it means they're gonna share the length. They're gonna share 100. Each equals equal to 50 millimeter. Reason radii. So we already have 50 millimeter here. 50 millimeter, 50 millimeter. I hope guys understand what I'm talking about here. Then now number 2. Number 2. It's so simple. We want QP. Now how will I find QP? Whereas I can use Pythagoras, whereas I can just have TP only. But now they need me to they want me to find the value of QP. This is the question, the value of QP. Now I'm trying to use Pythagoras. How will I use Pythagoras when I have the longest side, which is called the side of QP? And I'm not going to be able to use Pythagoras because that line is too long, and Pythagoras said that it must have 3 sides, two known sides and 1 unknown, and it must be a triangle. So here's a triangle that I can use right now. I can use this one also. I can construct OQs, not a problem. For now, let me just concentrate on what I'm giving. Simple. Yes. Now, remember guys, I said to you, if you have a line from center to a chord that is perpendicular to the chord, that means QT is going to be equal to TP, because we have a line from center that is perpendicular to the chord. Line from O to T is perpendicular to QP. We are given 90 degrees. Angle T is equal to 90 degrees. So angle T equals 90 degrees is given. And when in situations like this, that means QT is equals to TP. Reason, perpendicular line from center to, you can just finish it up guys, center to chord. Perpendicular from center to chord. Perpendicular line from center to chord. Guys, you can just write it in full. It's not a problem. I hope you guys understand where do we come from in terms of explaining the concept of QT that is equal to TP. Then therefore we can be able to find the value or the length of TP and add. Since we have the length of TP, we are able to say since TP is equal to QT, that means the length of TP is going to be equal to the length of QT. Then I'm going to add QT plus TP is going to give us QP. Simple. Then number 3, you can use Pythagoras. Let me just write fast guys. Pythagoras theorem. It says that the longest side OP, you can just use Pythagoras in different ways as long as it is according to the rules, or it is according to the theorem of Pythagoras. OP squared, it is our hypotenuse side, equals to OT squared plus TP squared. Reason from Pythagoras. So guys, in triangle OTP, OP squared is equals to OT squared plus TP squared. Then OP squared is equals to 50 squared, because OT squared is equals to 40 squared plus TP squared. So you can just use your calculator. So therefore TP squared is equals to 50 squared minus 40 squared. Then TP squared is equals to you can just punch your calculator, it's not a problem. So if we're not, you have a calculator, you can just use a calculator to find TP, is not a problem guys. So you can just say 50 squared on a calculator, or 50 squared is obviously 2500 minus 40 squared is equals to 900. I hope you understand. I hope you know the math. 900. Then after that you're going to introduce the square root on both sides. 900 square root. Square root of 900 obviously is 30. Therefore QP is equals to 30 plus 30. 30 of TP is equals to QT. TP is equals to QT. QT is equals to TP equals to 30 millimeter here each. Then when you add 30 plus 30 is equals to 60 millimeter. Then you are done with this question, guys. I hope you understand this question, where it comes from and where is it that is going, where is the direction it is taking. So let's just go to theorem 1b, the converse. The converse of theorem number 1. So guys, the converse means that it is the slight opposite of theorem 1. Slight opposite. It is not, it is similar but not the same. Yes, but it is the opposite of what you have said, meaning it is something and you're gonna prove. So it is the opposite basically. Let me just not narrow it. Yeah, so let's just read the theorem. The line segment for joining the center of the midpoint. When you talk about midpoint, guys, midpoint, it means if we talk about midpoint, there must be some bisecting sides there, if I'm not mistaken. I will just explain it. The line segment joining the center of the midpoint of a chord is perpendicular to the chord. So guys, in this case, this one is so simple. It's so simple. It says that if you have a line segment joining the center of the midpoint, we have a line segment joining the center, meaning you have line AB, our chord, it joins OC. If we have OC, if we have a line segment joining the center of the midpoint, this is our midpoint of a chord AB, is perpendicular. Now we are given 90 degrees here. Is perpendicular to the chord. So you need to prove that indeed OC is perpendicular to AB. This required to prove that OC is perpendicular to AB when we have a midpoint of midpoint C. If we have a midpoint, that means AC is equals to CB. That is the rule of midpoint, by the way. So you are going to prove OC is perpendicular to AB. So right now, so in this case, you do not need to prove congruency because you have already proven it. You just need to know the theorem and the reasoning. So if we are only given, maybe in the examination, only given that OC, it is, or I mean OC, it bisect AB only. I mean if you are given that AC is equal to CB and you have a line from center to a chord that bisects, or that is bisected, meaning AB is bisected. So if you are only given bisection, that means therefore OC is perpendicular to AB. Why do we say that? Because it is a line from center to midpoint chord. Line from center to midpoint chord. This is the reason you're gonna use. If and only if you're given lines that are visible bisecting lines on the diagram, then you're gonna prove okay. If you are given lines that bisect each other, that means OC is perpendicular to AB. Reason, line from center to midpoint chord, guys. I hope you understand this concept. So this is the opposite of theorem 1. There's nothing big here. So let's just go to an example. Simple one. Simple one. I just taking this from my previous question papers, obviously. We are given a circle. We're given a circle. Let me just change the color. Yeah, let me just change the color of the cook. We are given a circle with center O, and a chord AB. Chord AB, guys. AB is equals to 16. AB is equals to 16 what? 16 centimeter. C is the midpoint. C is the midpoint of AB. AO is equals to 10 centimeter. Determine the length of OC. OC OC, ne? So simple, guys, so simple. I've just taught you if you're given that AC is equal to CB, or if you're given lines that are or a chord that is bisected, meaning if you're given that let me just draw the statement and reasoning so that I can just finish everything up now. Yes, if you have a statement and reasoning now, statement and reason, guys. Sorry guys for not using a ruler, but next time I'll always use it. Yeah. So number one, guys, we are given that AC is equals to CB. Given. There's nothing can do. It's just given. Number two, if we are given that AC is equal to CB and we have a line from center to the chord that is bisected, the chord that is bisected, it means okay. Therefore, OC is going to be perpendicular to AB. Reason, guys. Reason. Remember, guys, I've told you the reason. Let's just go back so they can just remember where does it comes from. If you are only given bisected chord, when I given the chord that is bisected. So here's the chord that is bisected, and the reason is that if OC is perpendicular to AB, that means we got line from center to midpoint chord. Line from center to midpoint chord. So it is line from center to midpoint chord. I hope you understand where this thing comes from. If and only if you are given a chord that is bisected, then you wanna conclude okay, OC is perpendicular to AB. If and only if you have a center, a line from center to a chord that is bisected by a chord. Yeah. Therefore, OC is perpendicular to AB, reason line from center to midpoint chord. You are done with the reasoning here. So we're gonna include those 90s and it. And then we've just proven AC is equal to C. That means the length of AC is going to share with AC is going to share AC and CB. Those two sides are going to share the length. Basically, each is going to be equal to 8 centimeters. Each AC 8, CB 8 from 16. We're gonna share again. So number 3, let's just prove Pythagoras. Pythagoras theorem. It says that you must find the length of OC. Simple. So let's just prove Pythagoras, guys. OA squared is equals to AC squared plus OC squared. Reason Pythagoras. OA, what is the value of OA? 10 squared. AC 8 squared, remember, plus OC squared. 100 is 100, and 10 squared is 100. 100 minus 64 is 36, equals to, I have transposed 8 squared to the left side. I'm left with OC squared and square root. Because of this squared, square root on both sides, plus or minus. We don't have a minus length, hence I'm only gonna include positive answer here. Then the length of OC is equals to 6. I hope you guys understand. Therefore, OC is equals to 6 centimeters. Then you are perfectly done. Then the last theorem, theorem number 1C. This one is, it might be exam number. I'm not sure about. Let me just explain it for the sake of other people who might perhaps want to understand it. Yes, this one is so confusing, but I will try to put it on record because they might need it at some point. I'm not sure about its examinability, but I think it is also examinable. So I think it is also examinable. Yes, guys. So now this one is so simple. So now we are given a circle with a chord AB that is bisected, AC equal to CB visibly. So then we are given that C1 is equal to 90 degrees visibly. Then we have a line TC and we have center O. Theorem 1C is that the perpendicular bisector of a chord passes through the center of the circle. Perpendicular bisector of a chord passes through the center of the circle. Perpendicular bisector of a chord, it passes through the center, meaning this line, it passes, this line, and here we have a perpendicular bisector. TC is perpendicular to AB, and that means we need to prove that indeed O, it lies on TC. Center O, it lies on TC. That's the reason. That is what you're going to prove here. So perpendicular bisector of a chord passes through the center of the circle. This line, it passes through OC, or this line TC, it passes through the center, which is center is O, meaning O is part of this. It is part of this triangle, or this functioning that is happening inside the circle. So that's, we're gonna prove that indeed O is part of the circle. Yes. Then you are, what is it that is given here? We are given that circle center O, chord AB, then TC is perpendicular to AB, and AC is equal to CB. We are required to prove that O lies on TC, not TM, guys. Sorry, TC, TC, not TM, TC. O lies on TC. I hope you understand. O, center O lies on TC. So simple, ne? So let's suppose that O does not lie on TC. Let me just say, okay, O does not lie on TC. You need to prove that O lies on TC. But now let's just assume that O does not lie on TC. This is the proof by assumption. We assume. Let's just prove it, guys, by all means necessary. This one is gonna need me to just let's just prove. Therefore, C3 is equal to 90 degrees. C3 is equal to 90 degrees. Reason, line from center to midpoint chord. Let's just go back. C3, here's our C3. It says that is equal to 90 degrees. Reason, and you remember we said that a line from center to a chord is perpendicular. A line from center to a chord is perpendicular. Hence, we're gonna say C3 is equal to 90 degrees. Reasoning, line from center to midpoint chord. But C3 plus C2 is equal to 90 degrees. It is given. Remember, guys, if we have C2 plus C3 is equal to 90 degrees, it is given that C2 plus C3. Remember, if it bisect, that means angle C, meaning angle C2 plus C3 and angle C1, each equal to 90 degrees. Hence we're saying C3 plus C2, it is given that it is equal to 90 degrees, and C1, it is also given that it is equal to 90 degrees. And again, C3 now is equal to 90 degrees. Reason it is a line from center to midpoint chord, but C3 plus C2 equal to 90 degrees, it is given. So guys, remember guys, here we talk about remember, this is impossible unless if and only if C2 is equal to 0 degrees, meaning we have a C3 is equal to 90 degrees, we have C2 plus C3 that is equal to 90 degrees. So now if I want C2, now I want C2 plus 90, and C3 is equal to 90 degrees, 90 is equal to 90, then C2 is equal to 0 degrees. This will be true if C2 is equal to 0 degrees. So this is impossible unless C2 is equal to 0 degrees. Therefore, O lies on C. O, it lies on C. This is going to be true if C2 is equal to 0 degrees. Therefore, O lies on C. Reasoning, perpendicular bisector of a chord. So guys, this theorem, I will not dwell too much on it because I don't think it is examinable according to my experience, but for the sake of safety, just understand what is happening here. Then if here's the last question, guys, let's just answer it. So AB is the chord, AB is the chord, AB is the chord, AB is the chord of the circle with center O. Obviously our center is O, and is 24 centimeter long, meaning AB, it is 24 centimeter from A up to B. it is equal to 24 centimeter, guys. Is 24. Yeah, 24. Then C is the midpoint. C is the midpoint of AB. Midpoint, obviously, do you remember Theorem 1b? It says that if we have a midpoint, that means AC is going to be equal to CB, such that CE is perpendicular to AB. CE is perpendicular to AB. That means angle C, it is 90 degrees. Each and every angle that form part of point C is equal to 90 degrees. And it cuts the circle at E. Calculate the value of X if CE is equal to 8. Guys, this one is so simple, straight and straightforward. So I'm going to remind you of some valuable statements I've uttered during the first session, when I alluded specifically on the concept of radii. So I'll just point out a few important comments I've made, and I'm going to explain them shortly. Yeah, let's just check what did I say about radii. For a line or a side of a triangle to qualify to be called a radii or a radius, and get areas. A radius, it is a point from the circle of the center of the circle to the circumference. That line is called a radius. When you have more than one line performing the same function as a line that touches or that's from the center to the circumference, being called a radius. Yes. So if it qualifies that means that line is a radius. But if it is more than one line, that more than one, you can have two lines and etc. Those two lines and more, lines, we call them radii. More than one. Plural, more than one. Singular, radius. Plural, radii. So AO plays the same role as OB. Even OE is the same, because this line OE starts from the center to the circumference. That means OE is also our radii. It is part of the radius. So we call AO, OB, and OE radii. And radii are equal in lengths. That means the length of OE is equals to the length of OC. I mean OE. OA is equal to the length of OB. Yes, guys. So what is the length of OE? What is the length of OE? The length of OE is it is X, and OC plus CE equals to the length of OC plus CE. So OC is X and CE it is 8. When you add X plus 8, it's going to be equal to X plus 8, and is equals to obviously the length of OE, X plus 8, obviously X plus 8. I hope you understand what I'm trying to bring about to the house. This means the length of OE is the same as the length of AO and the length of OB. So we have X plus 8, X plus 8. I hope you guys understand. Then now let us solve, or let's find the value of X in that case. So statement and reason. So you can just construct the statement and reason table so that you can orderly write to answers. So the first statement from the table. So guys, go back to the theorem number 1a and start refreshing your mind. When I talk about radii, what I'm talking about, when I'm talking about chords and midpoints, what I'm talking about, and stuff like this, so that you can answer this question. So this question requires you to understand those concepts that I've touched. Yes. So now number one, it's so simple. Let us make everything to be possible, or let us make everything to be easy for all of us. So for you, if you don't understand, go back to what I've taught you in the very same video. So we need the value of x. Simple. Obviously, if AC is equal to C, that means the length of AC is equal to 12 and the length of CB is equal to 12. When I add 12 plus 5 is 24, the length of AB. Simple. So for AC, I have 12. Then for OC, I have x. Then for AO, I have x plus 8. Pythagoras theorem, because I have right angle triangle. So the hypotenuse side is AO squared is equals to opposite side, it is OC squared, plus the adjacent side, it is AC squared. Why? Pythagoras. So it is statement and reason. Statement and reason, guys. Yes. Then what is the value of AO? X plus 8. X plus 8 squared. X plus 8 squared is equals to, what is the value of OC? X squared. Then what is the value of AC squared? It is 12 squared. Then guys, x plus 8, when you simplify it, you're gonna be left with or when you simplify using the FOIL method, having two brackets and multiplying them out, you're gonna be left with x squared plus 16x plus 64 is equals to x squared plus 12 squared. Then like terms there. So let me just remove x squared, because when I transpose this x squared to the set, I'm going to left with x squared minus x squared is going to be 0. So you no longer have x squared. Then on this side, I'm left with 16x equals to 12 squared is 144. Then I transpose that 64 to that side. I mean, I take that 64 and transpose it to the right hand side. Then my answer is going to be obviously 80. Yes, so about 80. Then I want to be left with x. Then the value of x is equal to 5. I hope guys you understand where does that 5 comes from. So you can just substitute where you see x, you put in 5 and find the sides, the values of those sides that you don't have them. So the value of OC, or the length of OC, it is 5. Then the length of AO, it is 13. 5 plus 8. I mean, yeah, 5 plus 8 is 14, I guess, not 13. So guys, yes. So guys, I hope you have captured. I hope you have captured the lesson. I hope you're gonna meet again. Yeah, 13, not 15. So guys, yes, I hope you're gonna meet again in the next lesson. Theorem 2. Yes, so have a nice day. Thank you very much. Is it?